Hi everyone, how are you? I hope you're doing great and you're having a good day or evening. My name is Elisa and I founded Girls in Quantum in 2021, in 2022 actually, to democratize the access of quantum computing and share with others about this emerging technology. Today, I'm so happy because I have a great interviewee today and she's Lauren Capelluto. So that's how I pronounce it, right?
Yes, that's right. Great job.
Okay, awesome. And I'm so happy because, well, she will tell us about her experience and background in quantum computing. And yeah, I'm so excited. So, hi, Lauren, how are you?
I'm doing great today. Thank you so much for having me today.
Awesome. So, I didn't want to share much details because I want you to introduce yourself. Please, Lauren, could you introduce yourself to the audience?
Yeah, definitely. Hello, my name is Lauren Capelluto. I'm a software development engineer at Amazon Web Services or AWS. My job is focused on building Amazon Bracket, which is a fully managed service for researchers and developers to help them get started with quantum computing. So at AWS, we make quantum computers available through the cloud, just like we do with any other kind of compute resource. I've been with Amazon Bracket for over a year, but I also have 5 years of prior experience in the industry, working with IBM Quantum and Rigetti Computing.
Awesome. No, that's lovely to hear. And well, I'm going to start with, for example, the beginning of everything. So I was wondering, how did you get into this field, into perhaps not necessarily quantum computing, but for example, software, getting into Amazon Bracket. So I'll be more than excited to hear that.
Yeah, definitely. Going way back, there were two moments that were pretty pivotal for me that led to my current role. And the first one was in ninth grade, start of high school. Um, I had the opportunity to sign up for a science research elective, and I decided to do it. And the next year, when the class started, the very first assignment was just for us to figure out what kind of science is interesting to us, like what field, what subfield. And so I did a crazy Wikipedia rabbit hole search and I came across some weird thought experiments in quantum mechanics, like Schrodinger's cat, which is this really popular image of is the cat alive or dead. Definitely recommend people to read up more about it. It's really interesting. And when I read that in high school, my heart was like pounding. I thought it was the craziest, most thrilling thing ever. So that got me really excited about physics, and I ended up pursuing a physics and computer science double major when I went to university. And I like your background there as SF. I went to school at UC Berkeley, so I was like right around the corner from there.
Oh, that's
Um,
awesome.
and the second moment, I did promise a second moment, was my last year of university. Um, I had been doing physics and CS, and all my CS friends kind of had return offers. They had jobs lined up, and some of my physics friends were like, maybe I'll do a PhD, and they were working on that. And I was exploring different options, and I ended up just on a whim deciding to go to the career center and just have a career conversation. And kind of by a pure stroke of luck, it came up with I ended up learning about a quantum computing startup that was 2 miles down the road. And I would have had no idea that it was even possible to pursue a career in quantum computing until that came up. And that's how I found out about Rigetti computing. And I applied, and that's how the journey started for me. So it's been about 6 years or so now in this industry.
Wow, no, that's great. And it's great to hear that also it started in high school actually, like taking what some physics courses. It's great because well, most of our students are in high school right now. We're learning different topics. Some of them are really curious. For example, in Girls in Quantum, some students are really curious about biology. And I've shown, for example, some students as well, how quantum computing can have certain applications to biology. And it's so great to see how many interests can intersect in this field. I'm really interested in knowing if you've been always interested in science, or if you have someone who has inspired you, perhaps. How was that interest? How it was born?
Yeah, I feel like when I was younger, I was the one who was like, I'm not going to guess what I'm going to do when I'm older because whatever I guess is going to be wrong. And I want to be right about whatever it is. And I knew that there were certain areas that I was less interested in. One thing I really liked about science and mathematics is that you don't have to memorize a lot of things. I didn't like that. Even biology started being a little bit difficult for me because as you move away from math and physics and you start going into the chemistry and then biology, you have to remember more and more. And that was hard for me. But I had pretty broad interests. I wouldn't say that I really knew what I was going to do for a long time, but I just went in the direction that seemed interesting and I thought would have good opportunities. I was also interested in art, and I could have maybe seen myself go in that direction. But when you have software as a interest as well, it just felt a little bit more practical too.
Awesome. No, it's great. And well, now that you mentioned about software, I'm also curious about getting to know how do you, for someone who doesn't even know about this, for example,
Mhm.
how would you explain this correlation or this relationship with software and quantum computing? How does it relate together?
Oh yeah, so this is a good question, and it's extra interesting for me because, like I said, I pursued a double major in physics and computer science. I was kind of introduced to computer science while I was doing that research elective. I was doing a physics internship, but the work I was doing required me to learn a little bit of C code, and I like didn't know the first thing about software. I didn't know what C was. I'm like, what do you mean it's a language? I didn't understand how like a computer could understand code. It was like way over my head at the time. But I kind of thought it was cool and I started pursuing both degrees. I couldn't really decide what to do, so I just kept doing both of them and it kind of worked out. People kept asking me, "What are you going to do with that combination, physics and computer science?" And I was like, I don't know, like I'll figure it out, I guess. And then when I got into the industry, into quantum computing, it was like now everybody had a background in physics and computer science because quantum computing as a field kind of was born from this application of computer science principles and like information technology ideas to physics. It was like this idea like we're trying to compute things, we have interesting problems we want to solve, but the world is fundamentally quantum. So if we want to solve questions about the world, then our compute system should be quantum mechanical as well. And there's like a really famous quote from Richard Feynman that basically says that exact thing. You better, by golly, make a computer that's quantum mechanical.
No, that's awesome. And well, you mentioned about, of course, learning how to code, right? So I think that as a student myself, I've learned that like every single person that I talk with, they tell me about how important is coding, for example, and incorporating that in your personal life, whether you're going to be in the STEM area or not.
Mhm.
It's actually you can use it for everywhere and anytime. So I was wondering how has, for example, coding, learning how to code, whether it's in C or other languages, has shaped who you are, perhaps in your work experience. Yeah.
Yeah, yeah, definitely. I love this question. I'll definitely second your idea that like even if you're not really going into software, I feel like it does have applicable skills. Like even if you're building a personal website, for instance, it gives you a lot of extra room to express your creativity if you can control all of those elements yourself. But the reason I love this question is because going through my undergrad career, there was one class. in particular that was about proofs and algorithms and really understanding difficult algorithms and different complexity classes, just like kind of really getting into the heart of computer science finally. And I think that class completely changed the way that my brain works. I now So computer science is kind of the study of procedures at a really fundamental level. So now when I'm like faced with a decision problem, I'm applying what I know about computer science because I'm going through a procedure, right? And so it definitely affects the way that I live my life. If it's like if else statements in my head, if I do this, then this will happen, else this will happen. And I don't know if this is really relevant, but I have read a
Yeah.
book. It should be somewhere on my bookshelf. Anyways, there's a book, Algorithms for Life, and it is all about this concept, and I really enjoyed it. Maybe somebody would also enjoy picking that up.
No, for sure. And I think that I will link that in the description down below in the video, because all the students are also really like eager to learn more. In general, for example, if you have any recommendations, I'll note it down. But yeah, I was also wondering, so you mentioned about coding, for example, and you're really excited about it. You can notice that you're passionate about it. I'm so happy about it. And I'm also wondering what makes you enthusiastic about the future in this field, whether it's computer science, quantum computing, what makes you excited in, for example, different projects that you want to execute, or perhaps potential applications.
Yeah, so I've been in this industry for a while, right? Like I said, and building a quantum computer is incredibly hard. There is a long way to go before the systems are going to be broadly adoptable by business. And we need to learn collectively how to build and operate better quantum computers. And that starts by making the best systems we have available today just more broadly accessible, right? And Amazon Bracket helps people explore quantum computing. So, by making this more accessible to the research community, we can accelerate innovation. Researchers and developers can focus more of their efforts on developing those new algorithms and novel computing techniques. And eventually, of course, we're all very hopeful and excited for the day when quantum technology can be used in real world production applications, not just real world research, learning more about quantum computers applications, because it has a huge impact to huge potential to impact a lot of different industries. And AWS is also developing some of its own hardware and quantum error correction protocols and algorithms at the Center for Quantum Computing, which is another quantum technologies org within AWS, which is like a sister org to Amazon Bracket where I work.
For sure. And well, I've visited the website, of course, and I've seen all the things happening right now about quantum computing. And you mentioned about research. So also I would like to ask you, how does, for example, Amazon Web Services and Amazon Rocket perhaps collaborate with different scientists, researchers to advance in this field?
Definitely. Amazon Bracket does collaborate with academic institutions and researchers. So I'm a software engineer, but I happen to be on the Bracket science team. So I get to really see this in action. And myself and my colleagues are all encouraged to collaborate with researchers. Sometimes we'll invite academics to give talks to our team. The science team also will attend conferences in the industry and will share our own findings and also stay up to date with what the industry is thinking about, talking about, learning. And there's also more formal engagements between Amazon and academia as well. So we have an Amazon Scholar program, and this allows tenured professors to work part time with Amazon. Um, John Preskill from Caltech is one of the most respected researchers in quantum information science, and he's an Amazon scholar. So we're very lucky and fortunate to have him. And lastly, there's also an AWS Cloud Credits for Research program. I don't think this is specific to Bracket, but it means that anyone doing research and using Amazon Bracket can apply for credits to offset costs of their research.
Awesome. No, that's great. And well, from all the books you have behind, I think that you like learn you like learning more. You like reading. So I will later also ask you about how do you like find yourself this time to learn about new topics. For example, I think that well, in general, if you communicate this to other students about learning about science, it's continuously learning, continuously challenging yourself. So
Mm-hmm.
I'm really interested in that. And how do you find yourself in this time of learning new things? I imagine that your work, you know about computer science and physics, but you continuously learn. So could you please
Mm-hmm.
tell me more about that?
Yeah, that's one thing that I really love about working at Amazon Bracket is it's encouraged to do that. This week, for instance, I am giving a presentation to my team in our journal club, and that means that I have to read a paper and understand it well enough to present it as well. Um, so there, I would say there's kind of two categories of opportunities to learn. The first is stuff like this, where I have an obligation, I'm trying to get something done, and you just have to learn along the way. You're trying to implement something, and you just need to do some research to figure out how to do it correctly. And there's also a big doc writing culture here. So it means that if you're proposing something, you have to really understand why you're making that proposal, and that involves some research as well. The other side of it is carving out time for yourself to pursue things that are really interesting to you. And that I admit is a lot harder because you're like, oh, like I'm not like I really want to keep working on my main projects. I don't have time for this other thing. And sometimes it's hard to be like, no, it is important to make time for that. And sometimes you can kind of like find ways to work it into your regular work. But I think for that category of thing of where you're like really carving out that time for yourself to learn things that you're interested in, it really has to come from that interest, right? You have to foster that curiosity and just work towards understanding something that you're really curious about.
Totally. And well, I think that I completely understand that because well, I think that in Girls in Quantum as well, we try to just encourage more students to learn more. Right now, for example, some students are creating a beautiful book about quantum computing and geopolitics. There are honestly many topics that you can start investigating more, reading. For example, there is a new book right now. There is quantum in pictures. So definitely lots of opportunities right there. And well, between all these topics, um I also want to ask you about, for example, what's your favorite one, if you have a favorite topic in quantum computing. And yeah.
Yeah, so uh going back to how I got into it, right? I had heard about these weird thought experiments, and
Yeah.
ever since then I've always found quantum foundations to be super intriguing. This is the area of quantum mechanics that's interested in interpreting and understanding the counterintuitive mathematics of quantum mechanics. And I do say it's counterintuitive, but the math is definitely still accessible to anyone. You just have to work at it a little bit. It's basically algebra. It's not even as complicated as like calculus, right? And I'm sure in high school you guys have already probably taken algebra. Somebody's always asking, why am I learning this? Why do I need to know this? And it's like, okay, because it gets more complicated, but it builds on the same basic stuff. I haven't done any of this in my own work. I haven't worked on quantum foundations, but I've always found it super fun to think about and listen to what people are thinking about it. Um, and more recently, I've started thinking about quantum error correction. And fundamentally, quantum computers are analog devices, so there always is going to be some noise. And to suppress these errors and get something more perfect, we have to use quantum error correcting codes. And these codes are only possible with low enough physical error rates. And now our like physical error rates on our quantum devices are getting lower and lower. And so as the physical error rates get lower, the overhead required for quantum error correction also gets lower, and so it becomes more feasible. And there's also a lot of really cool research going on that's finding more qubit efficient ways of like doing these codes. So this area is only going to grow in importance, and I'm trying to make sure that I am getting up to speed along the way.
Oh, that sounds really good. And well, I think that in also in your background, with your background in well in physics and computer science, and also working with Amazon Web Services, I'm curious to know what has been like, or which project has been your favorite ones that you've been working with, perhaps in Amazon Web Services. If you have, for example, a research that you've been working for some years, what are currently the things that really excite you about working with Amazon Web Services. And yeah.
Yeah, so I could talk about the work that I'm doing, but since it is specific to Amazon, I kind of want to talk a little bit more about the culture potentially.
For sure.
So one thing that is really exciting to me working here is the way that Amazon lives its leadership principles. So definitely kind of like a switching focus here for a moment. But Amazon has a set of leadership principles. There's like 14. You can look at them all online. And these are the foundation for the culture at AWS. There isn't really a strict ordering between them, except that customer obsession probably comes first. And I'm really impressed with the way that the leadership principles guide the day to day work here. So, whatever project I'm working on in any meeting, you might hear somebody say, is this the best solution for the customer? Or how can we take a more customer centric point of view? And I really appreciate this because I feel like my work is most meaningful when I'm producing value for my customer. Sometimes the customer is internal, it could be my colleague on another team. And, sometimes it's external, it's the people actually using Amazon Bracket, right? Um, and specific to quantum, what I'm really happy about within Amazon Bracket is we can apply these leadership principles also to um, this industry in particular. So, like, one of the leadership principles is think big, but another one is earn trust. And sometimes you have a bit of healthy tension between these. And what that means for us here at Amazon Bracket is that we're going to think big. We're going to try to push the boundaries of what's possible, but we're not going to overpromise on this like emerging technology, this very young technology, right? So I appreciate that we can push to deliver as much as possible for our customers without giving into the hype that is surrounding this field.
Awesome. Yeah. And well, you mentioned about leadership, right? So I think that in general, when, well, in the school, we're really always, our teachers are saying, well, collaboration is key, right? We get to engage with other people, share perspective and discussions. And as you mentioned, it could also help and lead to better solutions. So I'm curious to know as well, like, how do you interact with other people that perhaps are not just in physics, but in other areas, and how you all kind of integrate your work together?
Yeah, one of the things I love about this industry is just how interdisciplinary that it is. So there are researchers in chemistry and finance and machine learning, optimization, uh, and there are electrical engineers, mechanical engineers, supply chain managers, especially in companies that are building their own hardware. There's such a broad set of skills that are required to get everything to come together, right? Even within physics and software, there's quite a range of backgrounds. You have theoretical physicists, you have device fabrication researchers, you have people running experiments, designing devices. It's really broad, and people with various levels of experience also have their place in quantum, including new grads. And it's not only technical roles, there's product managers and project managers, marketing experts and public relations experts, and also lawyers. And a lot of people enter quantum computing with expertise in their area, but no previous experience in the field. I mean, especially since it's a field that's growing right now. So, yeah, there's plenty of opportunities to collaborate cross-disciplinarily. Um, and in my day-to-day, like I'm having meetings with people all the time. I really enjoy it. I like having that collaboration and discussion. I did mention earlier too that there's a big doc writing culture at Amazon. So when you're writing a document, it's mostly an individual task, but you're never going to write a document just for yourself. I mean, maybe if that's part of your learning process, sure, you can. But the purpose at Amazon is that you're going to get other people to look at it and give you feedback and do rounds of review until you come up with the best solution.
That's remarkable. And yeah, well, I think that I've learned a few things from you right now. So you're really curious about learning, for example, and exploring and collaborating with other people. But you also mentioned some skills, for example, that are important in terms of coding and collaborative work. So what other skills would you like to add in this sort of in this aspect of not just necessarily science, but also quantum computing that are needed today?
Sure. So, yeah, if you're looking at the kinds of skills and expertise that we're interested in the field, I have just been talking about how much I like the leadership principles. And in fact, every job candidate at AWS is interviewed to assess their strengths against multiple of these leadership principles. So this is definitely something that is important no matter who you are, when you are. Like in high school, you can definitely be taking the time to show ownership on a project. In our interviews, we'll say like, let's let's think up questions that can give the candidate an opportunity to demonstrate how they insisted on the highest standards in the past or how they earned trust with teammates in the past. So at Amazon, we care about our candidates meeting this very high hiring bar. And also, we care that they're going to continue to grow over time. And we feel that the leadership principles are a really great way to assess that because if you take ownership over your work, you're going to, build in confidence and responsibility over time. I can also share some really like practical tips, really specific to quantum. I mean, maybe more specific to software than to quantum. Because if you
Tell me.
are interested in software and you want hands on experience today, I highly recommend contributing to the quantum open source community. So you can go on GitHub and there's public projects there, Penny Lane and Qiskit and Unitary Fund, and of course, Amazon Bracket all have open source projects that you can contribute to directly. And we love and highly value our community contributions. So it's a great way to meet the community, start building contacts, find out if you're interested in what another group is working on. And you can do that at any stage. It's really, I think it's so cool because it's just such a low barrier to entry, right? Like if you have a computer, you can interact with these communities, or if you have access to a device.
No, that's so cool. I like to share that with the students because they're really curious to learn more and always like perhaps get to know how it's working, for example, in quantum computing or
Hmm.
with some several projects. That would be so insightful for them. And I think that right now I have two main questions that I want to ask you. The first one is like your advice for students who might be interested in quantum computing, who might perhaps not know quantum, but like to get to know a little bit more about it. So what would you recommend them?
Yeah, there's a lot of resources online for this. There are actually, I do have there's actually a training workshop coming up
Oh,
in like 2 days that Bracket hosts, and I can send you the link. So this is supposed to not really require any background. It would be good to understand like Python programming for sure. But it's a free hands-on workshop that teaches how to use Amazon Bracket. And then it's 2 days. The first day is like basics of using Bracket, and then the second day is a little bit more advanced, talking about some like popular algorithms such as the quantum approximate optimization algorithm, and also an introduction to analog Hamiltonian simulations. So really cool stuff. I'll send you the link so that you can share it. It's the August 30th and 31st, 7 a.m. to 10 a.m. Pacific time. So it's coming up soon.
for sure.
But there's really a ton of resources online. IBM has a Qiskit textbook, and going through the textbook is pretty good. You can just go one chapter at a time and skip around to the pieces that are interesting. And one thing that's really nice about these projects is that you can uh, download these quantum software development kits, like Amazon Brackets SDK. And as you're learning any particular concept, you can at the same time be writing code to build whatever concept you're learning about. So, like the kind of hello world example of quantum computing is building a Bell state, which is a maximally entangled state. So, just learning how to build a Bell state in your SDK of choice, software development kit, and then learn how to run it just even on a simulator and kind of go through the process of proving to yourself that the results that you're getting are what are expected. That's where I would start.
Awesome. Yeah, no, that would be such a great thing for students to get to know that and explore those resources, especially that they are online right now, so they can access to them anytime and anywhere. That would be
Mhm.
awesome. And yeah, my last question is about the future, honestly. Like, what do you expect about the future of quantum computing, about your future by itself, your future, your personal future, like learning? Please, I'll be more than excited to hear that.
Yeah, at Amazon, we're focused really on the long term over the short term. And this is especially true at Amazon Bracket. We know quantum computing is a really long game and we're in it for the long haul. And I'm really excited to also be here for the long haul and continue to grow and develop my own career here. I feel like it's such a great team to do that with. But yeah, so we use this long-term vision to guide our efforts in the near term, of course. And as we're executing on it now, what this looks like is we're trying to increase the availability of quantum hardware on AWS. So more devices, more different kinds of devices, more hours of the day that these devices are available online. And it's kind of great timing to be talking about this because just last week, one of our quantum hardware providers, Quera, has increased the availability of their Acula device from 10 hours a week to 48 hours a week. So that's pretty neat. It's just one example of the kind of thing that we're trying to do. Um, and also to complement that, of course, we're building more tools for the quantum developer. We want to improve the user experience so they can focus deeply. Our end users research can focus deeply on their research and not worry so much about building and running and debugging programs. And one of the projects that I'm working on right now is an experimental extension for Amazon Bracket's software development kit. It's called AutoChasm right now. This is because it helps generate OpenChasm, which is the transport layer program representation that's accepted by the service. So basically, you're writing AutoChasm. It's like just normal Python, fully integrated with the Bracket SDK. But because it can be represented in the form that's supported by our service, you can just run those programs. It's not part of the main SDK. It's super experimental, but we're having a lot of fun building it. And that whole project is about how do we improve the customer experience, especially looking around the corner, because it seems very likely that in the near future, having more control flow in quantum programs is going to be really important. Like OpenChasm 2.0, no control flow. OpenChasm 3.0 has control flow. And it's likely that we're gonna, just like I was saying, quantum error correction, it's gonna become more important. Well, quantum error correction requires these more advanced forms of control flow. So the AutoChasm project essentially is how do we make that feel more natural? How do we make it feel Pythonic? And how do we make it the best possible customer experience? So I'm
No.
excited about it. Yeah.
Yeah, no, it sounds like I'm so happy about it because, well, it seems like so cool what we can expect for the future. Also, the way that we can perhaps some people can access for more quantum computers from Amazon Bracket, and it's so great that you're working on that, and also that you can share your experience with us, especially as students who might be able to pursue that in the future potentially. And for us, it's just a great insight once again. So I highly appreciate your time, Lauren. I think that your enthusiasm is contagious. So that's awesome to know that, to get to know about the mission of Amazon Bracket also and your work. So yeah, I really thank you for being here.
Yeah, thank you so much for hosting. It was lovely meeting you. I'm going to send you those links so that anybody who wants to uh, get up and started with quantum computing can have those resources available.
Sounds amazing. Thank you so much for being here.
Thank you. Bye.